Okay, today we're going to be looking at solving quadratic inequalities. Now, last week we were looking at solving quadratic equations, and we've gone over 3 different ways to solve a quadratic equation. One of the ways we did was graphing. Another way we solved a quadratic equation was factoring. And the last one, the one you did homework on, was a quadratic forming. So those are the 3 ways we have to solve a quadratic equation. Today we're going to be looking at solving quadratic inequalities. So, how are we going to do that? We're going to use graphing and factoring method. So it's not going to be totally new. We're going to go back and refer to some of the things that we talked about last week on that solving quadratic equations. Now, if you take a look at your notes there, you'll notice up at the top they give us 2 samples of quadratic inequalities. They are slightly different. It says there are 2 types of quadratic inequalities. They can be solved by graphs. What difference do you notice about these 2 samples? So if you look up at the top, these are different. Can you tell what's different about these 2 here? How are they different? What's that? That's right. One has a y, the other has a 0. So up at the top there, I need you to write down for me. One has a y, the other has a 0. Right up here at the top. One has a y, the other has a 0. Is that going to make a big difference? Oh yeah, it is. So what we're going to do is we're going to look at the one that has both an x and a y. That's what we're going to look at first. First thing you should notice is that one has 2 variables. It has an x and it also has a y. The first example they give us has 2 variables, an x and a y. And because it has an x and a y, the nature of our roots, or the solutions of that quadratic inequality, are going to end up being ordered pairs. All the answers we get for that inequality are going to be ordered pairs that make the inequality true. And there's going to be lots and lots of ordered pairs that make that inequality true. It's going to be our job to find all of them. How are we going to find all of those ordered pairs? Well, we're going to find those solutions by graphing the solution. Okay? Now here it says the graph of the solution is a blank bounded by the blank of the related function. The graph of the solution is going to be the shaded area that's bounded by the graph of the related function. So the solutions are going to be inside of our shaded area. And they give you an example of what your answer is going to look like. Down at the bottom there, they give us a graph of a parabola. Notice how that parabola has some shading. And all of that shading represents our solution. In other words, any ordered pair that I pick, as long as it falls within this shaded area, would represent a solution to our inequality. And there's lots of them. So the graph itself is the solution. It's impossible for us to list every ordered pair. So we just use the graph. Now, if you look at the other example they gave us, the other one has a 0 rather than a y. So we only have one variable on this, and the variable we're working with is x. And because there's only one variable, because there's only an x, the nature of our solution, the solutions are going to be the x values that make the inequality true. So now we're only looking for x. We're not looking for ordered pairs. We're only looking for x values. And those x values have to make the inequality true. And there's going to be quite a few of those as well. How are we going to find those x values? Well, again, we're going to be doing some graphing here. The graph of the solution is a set of x values that's bounded by the roots, or the solution, to our related equation. So we're going to be looking for the roots or the solutions to our quadratic to help us find the set of x values that make it true. So again, they give you an example of what the graph is going to look like. Notice rather than having a graph, like on the first one there, all we have is a number line. And all the x values that are greater than 2 or less than a -2 would represent a solution to this particular example they gave us. So our answers are going to look like that. So if we have a y, our answer is going to look like this. If we have a 0 rather than a 1, our answers are going to look like this, a number. So those are the two things we'll be looking at today. All right, let's start looking at some examples here. First thing we're going to do is look at how to graph two variable quadratic inequalities. So this one has both the x and the y. So here it says to graph the solution to two variable quadratic inequalities, we're going to start by graphing the boundary using the quadratic function. So in other words, we're going to go to our calculators and we're going to put in that quadratic. That way we get a picture of what the U-shape looks like. So everybody go to your calculator. Let's go to y equals. And all we're going to do in that y equals is type in 2 parentheses x plus 1 squared minus 18. Putting it in our calculator. And all we're going to do is we're going to transfer that graph you see on your calculator onto this graph paper right here. Now be careful because we do want to make this graph as accurate as possible. So you can either look at the graph, or it might be even better if you look at your table. Because if you look at your table, you'll get specific points, specific order pairs that would fall on our graph here. Now let me make sure you keep one thing in mind, guys. Before you connect these points, you need to keep in mind that when you connect those points, your quadratic, your graph there, may end up being a dotted line, or it may be a solid line. And how are we going to tell when to use a solid or a dotted line? Well, it tells us right over here. You're going to have to look at the inequality symbol. If it has an equal sign on it, like these do right here, we're going to use a solid line. If it doesn't have the equal sign on it, then we're going to use a dotted line. Now you'll notice the example that we're working with, it does have an equal sign on it. Therefore, when I make my U shape, my quadratic, make sure you use a solid line. Use solid lines when you have an equal sign. So again, right now all you're doing is transferring the graph you see on your calculator onto the graph paper. When you get done graphing that U-shape or parabola, we're also going to have to do some shading, because this is an inequality, so there is going to be some shading involved. Now we can do one of two things to get the shading, actually one of three things. One is to use a test point, and if that test point is true, that's where we're going to shade. If it's not true, then we would shade to the opposite side. Or we can go ahead and use the same rule that we had with linear inequalities, and that was, if we see a greater than symbol, we shade to the top. If we see a less than, we shade to the bottom. Okay? Now again, in this example, we're using a less than. So less than means we're going to be shading to the bottom of our U shape. So what's going to happen is we're going to end up with a graph that looks like this right here. So when it's all said and done, that's the graph we're going to get. Notice how we have a solid U shape, solid line. And notice how we're also shading to the bottom of the U shape. Now notice I said bottom. I didn't say inside. I didn't say outside. It's to the bottom of the U shape. Now remember I said there were three ways that we can get our shading. Test point, top and bottom. How about calculator? Can the calculator graph the shading part for us? Yes, the calculator will do shading for you. So let's go to our calculators for those of you that aren't familiar how to get the shading. Go to your calculators, and when you get there, right next to your y equals, your y1, out to the side you see a little line. Highlight that line. And what I want right now is the less than. I want it to shade to the bottom. So what you're going to do is you're going to hit enter until you see this little triangle right here. That right there is the less than. Okay? That's the less than. So go ahead and hit enter until you get that little triangle. Then go back to your graph. And you'll notice not only do you see your U shape, but you're also going to see the shade. So if you're not quite sure what side to shade, well, just cheat. Go ahead and use your calculator to get that shading done for you. So this is how we do it if we have both an X and a Y. Our graphs are going to look just like this. You're going to graph your parabola and shade either the top or the bottom. But again, be careful. Some of these parabolas may end up being dotted lines. Be careful. All right, let's go on. The next thing we're going to look at is how do you solve a quadratic inequality if there is no y? What if there's a 0? Well, here's a couple of steps that we're going to have to go through. Up at the top it says, first thing we're going to have to do is determine the roots by factoring or quadratic formula, whatever method you're more familiar with or you more comfortable with. If you like doing factoring, let's do factoring. If you like quadratic formula, well then do quadratic formula. Once we do that, what we're going to do is we're going to place these values on the number line using either open circles or closed circles, and we can tell what kind of circles to use. Looking right here, it says if we have a less than or greater than symbol, we'll use an open circle. If we have a less than or greater than or equal to symbol, then we'll use a closed circle, meaning we're going to include it. Once we have that taken care of, we're going to test each region formed by the number line and determine which areas give us true values. And then we'll shade that region on the number line. And those will be our solutions. All right, so let's go. First thing I got to do is take this x squared plus 3x minus 10 and solve that quadratic. Now I can either use factoring method or quadratic formula. I think in this particular case, factoring is going to be the easier of the two methods. So right now I'm trying to factor x squared plus 3x minus 10. So here we go. This is what we've been working on this week and last week. As a matter of fact, we just took a test on Friday over this stuff. X times x is going to give us the x squared. What can I multiply together to get negative 10, but are also going to add up to a positive 3? What are my factors? What two numbers can I get? 5 and negative 2. Let's try it out. 5, negative 2. When you multiply 5 times negative 2, you definitely get a negative 10. Notice when you add the 5 and the negative 2, you also get a positive 3. So you're all right. Those are the factors. What we're going to do with those factors is we're going to take each one of them and we're going to set them equal to 0. This does sound familiar, right? Remember us doing this. So we come over here, solve the first one for x. So one of my roots is going to be negative 5. Come over here, do the same thing. My other root's going to be positive 2. So the two roots of this quadratic are negative 5 and positive 2. So here's what we're going to do. We're going to take those two numbers and we're going to place them on the number line. Here's the negative 5. Here's the positive 2. By the way, keep in mind that the smaller number is always on the left, the bigger number is on the right. There's the number line. Now it says here that I'm going to place some circles on these numbers or on these two values. Question is, what kind of circles? The open circles or the closed circles? This is going to be open circles. And the reason I know that's an open circle is because there is no equal sign on my inequality. All right, so here's what we need to do next. The next thing we need to do is test each region formed by the number line. In other words, I'm going to take a point that's in this section of the number line. Give me a number that's in that red area. Any number that falls after the negative 5. Negative 6. There's lots. There's lots. I'm going to go ahead and use negative 6. What we're going to do is we're going to take that negative 6 and we're going to plug it in to that inequality. So in other words, I'm going to do this here. 0 is greater than negative 6 squared plus 3 times negative 6 minus 10. So all I'm doing is replacing the x with a negative 6. I need you to put this into the calculator for me. A negative 6 squared plus 3 times negative 6 minus 10 would give us a what? 8. Positive 8 or negative 8? Positive 8. So my question to you is 0 greater than 8? Is that true or is that false? False. This right here results in a false statement. And I would get a false statement regardless of what number I chose. If I would have used negative 10, I still would have got a false statement. Okay, so now I'm going to test this region right here. So I need a number that falls between negative 5 and positive 2. Give me a number. 0. Okay, so I'm going to test 0. So what we're going to do is we're going to come over here take out all the x's, plug in a 0, and let's see what we end up with here. Again, going to your calculator, we're doing 0 squared plus 3 times 0 minus 10, and you get what number? Negative 10. So the question is 0 greater than negative 10? Yes, that is true. So right here I'm going to put true. I got one more area to test, and that's this one right over here. I need a number that's out in that area. What number can I use? What is it? 5? Okay, we'll use positive 5. So again, come over here. We're going to replace all those x's with a 5. We're testing this out here and seeing whether or not we get a true or false statement. So let's see what we get this. 5 squared plus 3 times 5 minus 10 would result in a what? What are we going to get? 30. Is 0 greater than 30? No. That is false. That is false. Now remember, it says we're going to shade the region of the number line where the area is true, which in this case is going to be this middle section right here. So everything between negative 5 and positive 2 would be our solution. So all of this and everything in between. Okay, so the actual graph, and I'll draw it over here so we can see the final answer. So our final answer is going to look like this right here. The solutions are going to be all the numbers between negative 5 and positive 2. All we did was test over here the negative 6. We test over here the positive 5. We saw that they were resulted in false statements, therefore we don't need that part of the graph. All we need is between negative 5 and positive 2. So that right there is our solution. All right, let's go on to number 3 here. Number 3 says we have a garden that is to be shaped like a rectangle. The length of this garden must be 4 meters longer than its width. The gardener wants the area of the garden to be no greater than 480 square meters. Find all possible dimensions. Find all possible dimensions. So here we go. Let's start by drawing our garden. Here's our rectangular garden. Now it says that the length is 4 meters longer than the width. The problem is we don't know what the width is. So I'm going to call the width X. Or we could call it W. We can call it anything we want. I'll go ahead and stick with X so I don't confuse anybody. Now if we're going to call the width X, and the length over here is 4 meters longer than that, what am I going to label this as? X plus 4, since it's 4 meters long. So the next question is, how do you find area of a rectangle? There you go, length times width, which in our case is going to be X times X plus 1. This is how we find area of a rectangle. Now notice how up there it says that the gardener wants the area to be no greater than 480. No greater than 480. So what inequality symbol am I going to have to use if I want to make sure it's no greater than 480? Like that. We want this area to be no greater than 480, which means it's got to be less than or equal to 480. I want to make sure I don't go over that. All right, so this is what I'm working with here. We want to find all possible dimensions. So we want to find the value of X. So what I'm going to have to do here is do some distributive property to start off with. So X times X is going to give me X squared. X times 4 is going to give me a 4X. Now, typically when we're working with our quadratic, we want to make sure it's equal to 0, because I can't do any factor. I can't use quadratic formula unless it's equal to 0. So the same thing is true here. I'm going to have to move that 480 over to the left so that I can have this thing, so that I can have this thing equal to 0, or in our case, less than or equal to 0. We got to do that first. All right, now that we have it equal to 0, now we're ready to either factor it or use the quadratic formula. What do you think is going to be easier to do here? Quadratic formula? I think factoring would be a little easier, but if you prefer quadratic formula, you're more than welcome to do that. I am going to do the factoring though, because I personally think it's going to be a little easier. I know that x times x is the x squared. I know I need to multiply two numbers together to get that negative 480, but they also need to add up to 4. I'm thinking somewhere in the 20 range. Help me out here. Let's play with some numbers. What two numbers can I multiply together to get negative 480? But are also going to, what's that? 24 and 20. What kind of 20 and what kind of 24? Positive 24 and negative 20. Let's double check this. Everybody go to your calculator. Let's do 24 times negative 20. Is that negative 480? Yes. Is it going to add up to a positive 4? Yes. So these are the correct factors. Now that I have those factors, now I can actually find the roots. We're going to take each one of these factors. We're going to set them equal to 0, and we're going to solve. So one of them is a negative 24, and the other is going to be a positive 20. All right, so these are the two solutions here, negative 24 and 20. So here's what we said we were going to do with those solutions. We're going to take those solutions, and we're going to put them on the number line. So here's my number line. The small number goes on the left, big number goes on the right. We're going to put some circles here. The question is what kind of circles? The open or the closed circles? Closed. We do have an equal sign on our inequality, so we're going to use closed circles here. And now I need to start plugging in some numbers here. We're going to test each of the three sections that we have to see which one results in a true statement. All right, so I'm going to start out in this area over here. Give me a number that's out in that area. Negative 26. So we're going to take that negative 26 and we're going to plug it in. The question is where? Where in the heck are we going to plug it in? We're going to plug it in right here. That's where we're going to plug it in. So here we go. Negative 26 squared plus 4 times negative 26 minus 480 is less than or equal to 0. All right, let's see whether we get a true or false statement. Put that in your calculator, and what number are we going to get? 92? Positive 92? Y'all double check the work. 92 less than or equal to 0. Is that true or false? False. That is false. Let's try the middle section. Number between negative 24 and positive 20. What number are we going to use? Give me a number that falls between negative 24 and 20. Something that falls in here. 0. 0 would probably be the easiest number to use. So we're going to do 0 squared plus 4 times 0 minus 480 is less than or equal to 0. So put that in your calculator. What are we going to get? Negative 480. Is negative 480 less than or equal to 0? Yes, that is true. So true right there. We got one more area to test. That's this area over here. What number are we going to use for that area? 25? Okay, we'll do 25. So again, let's plug it in. We got 25 squared plus 4 times 25 minus 480. 245. And because 245 is not less than or equal to 0, this would be a false statement. That is false. Therefore, our solutions are going to be in that area where we have a true statement, which is going to be everything from here to here. This is where the true area is. Therefore, this is where our solutions are. Now, we got a little bit of a problem here. We're not quite done yet. What did the question ask for? Find all possible dimensions. So I'm looking for a length, but I'm also looking for a width, okay? X represents our width. X represents our width. So to keep this straight, what I'm going to do is instead of X, I'm going to use W. And right now we're saying that the width is falling between 20 and negative 24. Right now that's what we're saying. Does that make sense? What's wrong with that? Ah, that's right. We can't have negative width. I can't say that this room is negative 24 feet wide, can I? No. What's the smallest value I can have for my width? 0. So I'm not going to use negative 24. What I'm going to use is 0. As a matter of fact, it can't be equal to 0, can it? It's got to be greater than 0. Okay, so our width is going to have to be some value between 0 and 20. Can't be equal to 0 because then we would have no width. But we're still lacking the length. So let's put in the length real quick here. Now remember, the length is going to be 4 more than the width. So all I'm going to do is take each of these values I have up here and do what? Add 4. So this now becomes 24. This one over here now becomes positive 4. So our length is somewhere between 4 and 24. So we got to think of it in terms of our situation. A negative 24, in this case meters, wide wouldn't make sense. So we have to start at 0. So this would be our possible dimensions. All right, so that takes us through quadratic inequalities.